Hello everyone, I'm Rafaela Malubanan, one of the members of Group 3, and we will be discussing the measures of variability. What is measures of variability? Measures of variability help us understand how spread out or scattered the data is. They show how much value in a dataset differ from each other or from the average. Basically, it tells us if the data is tightly packed or widely spread. Common examples are range, interquartile range, mean deviation, variance, and standard deviation. Now, let's discuss the common measures of variability. The first one is range. Range is the simplest measure of variability. It's just the difference between the highest and the lowest value in a data set. This gives us a quick idea of how spread out the data is. Second is the interquartile range. The interquartile range focuses on the middle or 50% of the data. It's the difference between the upper quartile or Q3 and the lower quartile or Q1. This measure is great for ignoring outliers and understanding the main spread of the data. Third is variance. Variance helps us see how far data points are from the mean or average. It's calculated by averaging the square difference from the mean. A higher variance means more spread in the data, while lower variance means the values are closer to the mean. Fourth is mean or average deviation. Mean deviation measures the average distance of each data point from the mean. Unlike variance, it doesn't use square differences, making it easier to interpret and a simple way to understand data variability. Fifth, or lastly, is the standard deviation. It is a widely used measure of variability. It's the square root of variance, so it's the same unit as the data, which makes it easier to understand. It tells us the typical distance of data points from the mean. Fifth, lastly, is the standard deviation. Standard deviation is a widely used measure of variability. It's the square root of variance, so it's the same unit as the data, which makes it easier to understand. It tells us the typical distance of data points from the mean.
Hello everyone, I am Unica and I am going to share to you the importance of measures of variability. The first one is understanding data distribution. Variability measures reveal how dispersed the data is. The data points are more dispersed when the variability is great, and they are grouped around the mean value when the variability is low. This aids in comprehending the data's underlying distribution. The second one is comparing data sets. Measures of variability allow it to be possible to compare various data sets. It can assess the relative variability of different data sets and indicate that one data set is more unstable or unpredictable while the other one is more dependable. Measures of variability can determine if differences between groups are statistically significant. Another one is making informed decisions. Measures of variability helps with the decision-making processes and with the assessment of reliability and precisions of measurements. Measures of variability are essential in psychological research. It can help with the interpretation of behaviors. It can assess the consistency and reliability of respondents' responses. It can help with the assessment of psychological disorders and with the calculation of statistical differences.
Now that we have a background about the common measures of variability, we will now discuss the process of computing each of them. Let's start with range. The formula in computing for the range is R is equals to the highest value minus the lowest value in the dataset. Suppose we have the following dataset of 8, 12, 15, 20, and 25. To find the range, we need to subtract the smallest value, which is 8, from the largest value, which is 25. This will give us 17, so the range of this dataset is 17.
Hello, this is Unica again, and this time I am going to discuss briefly how to determine interquartile range for group data. Our problem is given the ages of the following students 18, 19, 23, 24, 22, 21, and 20. Find the interquartile range for group data. First is we need to group the data into class intervals and compute for cumulative frequency. As you can see here in the table, class intervals is 18 to 20 with a frequency of 3 and cumulative frequency of 3. The next interval is 21 to 23 with a frequency of 3, cumulative frequency of 6. Last is 24 to 26 with a frequency of 1 and cumulative frequency of 7. So to find Q1, we need to divide n to 4. Our n is 7, so 7 divided by 4 is 1.75. 1.75 belongs to class in cumulative frequency of 3. So, we are going to use the class interval 18 to 20. Formula for Q1 is Q1 is equals to low boundary plus n divided by 4 minus CFB divided by F times class interval. We just need to substitute the data. So Q1 is equals to 18 plus 1.75 minus 0 divided by 3 times 3. So Q1 is equals to 18 plus 1.75 is equals to 19.75. Our Q1 is 19.75. After finding Q1, we will find the Q3. So to find Q3, we will multiply n to 3 divided by 4. So 3 times 7 divided by 4 is 5.25. 5.25 belongs to cumulative frequency of 6. This means that we are going to use the class interval 21 to 23. The formula for Q3 is lower boundary plus 3 times n divided by 4 minus CFB divided by frequency times class interval. So the low boundary is 21. The 3 times n divided by 4 is 5.25. Our CFB is 3, our frequency is 3, and our class interval is 3. So we will substitute the data into the formula. 21 plus 5.25 minus 3 divided by 3 times 3. This is 21 plus 2.25 equals to 23.25. Our Q3 is 23.25. After finding Q1 and Q3, we will compute the interquartile range using the formula IQR is equals to 20 Q3 minus Q1. Our Q3 is 23.25. Our Q1 is 19.75. So Q3.25 minus 19.75 is equals to 3.5. Our interquartile range for group data is 3.5.
Since you already know what interquartile range is, it's time to learn how to compute it. The problem given is we need to find the interquartile range of the ages of the following students, which are 18, 19, 20, 21, 22, 23, and 24. First, we need to arrange the data in ascending order, or arranging the dataset from lowest value to the highest value. After this, we can now get the median, which is the middle value of the dataset. Here in the given problem, the middle value is 21, which is the fourth value. After getting the median, we need to divide the data into two halves, excluding the median. The first half is the lower half, which are 18, 19, 20, coming from the left side of 21. The second half is upper half, which is 22, 23, and 24, coming from the right side of 21. Now that we have the lower and upper halves, We can now find the first and third quartile. To get this, we need to look at the middle value of the lower and upper half. So the first quartile is 19 and the third quartile is 23. Now, let's get the interquartile range. 23, or the Q3, is minus the 19, Q1, is equals to 4. So our interquartile range is 4.
Determining the mean deviation, variance, and standard deviation of group data. So for this example, we are going to use the problem. Given the data point 5, 7, 8, 10, and 12, find the mean deviation, variance, and standard deviation. The first step is group the data into intervals and compute for their frequency, midpoint, and frequency times midpoint. As you can see here in our table, we have the intervals. We have their frequencies and their midpoints and frequency times midpoints. After completing the table, we will compute for the mean. The formula for the mean of group data is summation of frequency times midpoint divided by summation of frequency. Our summation for frequency times midpoint is 42. Our summation for frequency is 5. So 42 divided by 5 is 8.4. Our mean for group data is 8.4. After finding Q1, we will find the Q3. So to find Q3, we will multiply n to 3 divided by 4. So 3 times 7 divided by 4 is 5.25. 5.25 belongs to cumulative frequency of 6. This means that we are going to use the class interval 21 to 23. The formula for Q3 is lower boundary plus 3 times n divided by 4 minus CFB divided by frequency times class interval. So the low boundary is 21. The 3 times n divided by 4 is 5.25. Our CFB is 3, our frequency is 3, and our class interval is 3. So we will substitute the data into the formula. 21 plus 5.25 minus 3 divided by 3 times 3. This is 21 plus 2.25 equals to 23.25. Our Q3 is 23.25. After finding Q1 and Q3, we will compute the interquartile range using the formula IQR is equals to 20 Q3 minus Q1. Our Q3 is 23.25. Our Q1 is 19.75. So Q3.25 minus 19.75 is equals to 3.5. Our interquartile range for group data is 3.5. After completing the table, we can now compute for the mean deviation. The formula for the mean deviation of group data is summation of frequency times midpoint minus mean divided by summation of frequency. Our summation for frequency times midpoint minus mean is 9.6. Our summation of frequency is 5. So 9.6 divided by 5, 1.92. Our mean deviation is 1.92. Next is to compute for the variance. The formula for the variance of group data is summation of frequency times midpoint minus mean squared divided by summation of frequency. Our summation for the frequency times midpoint minus mean squared is 25.2. Our summation for frequency is 5. So 25.2 divided by 5 is 5.04. Our variance is 5.04. For the standard deviation, we just need to find the square root of our variance. So the square root of our variance, 5.04, is 2.24. Our standard deviation is 2.24.
Let's proceed in calculating the mean deviation, variance, and standard deviation. First, we need to calculate the mean. The formula for the mean is equal to the summation of x divided by n, or the number of the data points. This means that we need to add all the data points and divide it by the total number of values. Let's add them all together. 5 plus 7 plus 8 plus 10 plus 12 is equals to 42. Now we divide it by the number of data points, which is 5. So 42 divided by 5 is equals to 8.4. So the mean average is 8.4. This is the center value around which we will measure the variability. Next is getting the mean deviation, which tells us, on average, how far each value is from the mean. It's the average of the absolute difference between each data point and the mean. The formula is mean deviation is equals to the summation of x minus mean divided by n. The x, or the scores, are the given data sets, which are 5, 7, 8, 10, and 12. And the next table is x minus mean. We need to subtract all of the x to 8.4. So we will end up with 3.4, 1.4, 0.4, 1.6, and 3.6. And then we add all of the values. So the total of the x minus mean is 10.4. And to get the mean deviation, we need to divide 10.4 to n, which is 5, and the mean deviation is 2.08. Next, we need to find the variance. In computing the variance, we need to square the values in x minus mean. The square root of 3.4 is 11.65, and the square root of 1.4 is 1.96. And we will do the same process to the rest of the values. After getting all the values, we need to add all of it, and we will get the sum of 29.2. Now we are ready to get the variance. We just need to divide the sum of x minus mean squared, which is 29, to n, or 5. 29.2 divided by 5 is equals to 5.84. So the variance is 5.84. The last part is getting the standard deviation. In getting the standard deviation, we need to divide the square root, or the variance, which is 5.84. So the square root of 5.84 is 4.42. So our standard deviation is 2.42.
I'm GME Gaspar, and I will be discussing the measures of variability for group data.
So I will be discussing the measures of variability for group data, including the range, variance, and standard deviation para dito sa ating scores of 40 students in psychological statistics exam. So una is, I do the array para organize yung ating data, and then i-organize na rin yung classes. And as you can see, nandiyan na rin yung ating frequency. So ngayon, paano natin ngayon kukunin ng class boundaries? So all we need to do is to minus 0.5 sa lower value ng classes and mag-add ng 0.5 sa higher value ng classes. So 70 minus 0.5 is 69.5. And then 75 plus 0.5 is 75.5. And then 64 minus 0.5 is 63.5. 69 plus 0.5 equals 69.5. Then, ganun din yung gagawin natin sa ating ibang classes. 52 minus 0.5 is 51.5. 57 plus 0.5 is 57.5. 46 minus 0.5, 45.5, 51 plus 0.5, 51.5, Now, we can now compute for the range. If sa ungroup data, sasubtract lang yung highest value sa lower value ng data. Dito sa group naman, ang isasubtract natin is yung highest class boundary minus lowest class boundary. So, ayan. And we have the highest class boundary 75.5 minus the lowest class boundary which is 33.5. So range equals 75.5 minus 33.5. So we have the range of 42. So pwede nyo na i-direct din sa calc nyo siya. So ayan yung range natin. Next is we are going to solve for the class mark. So ang gagawin dito is sa classes, pag-a-add natin yung 70 plus 75 and divided by 2. So 70 plus 75 equals 145 divided by 2. That's 72.5. 64 plus 69 divided by 2. We have 66.5. 58 plus 63 divided by 2. 60.5. 52 plus 57 divided by 2 is 54.5. Then 46 plus 51 divided by 2, 48.5. 40 plus 45 divided by 2, 42.5. 34 plus 39 divided by 2 equals 36.5. Then i-total na lang din natin tong n natin. So, n equals, so, i-add lang natin tong frequency. So, n equals 40. So, tama yung frequency natin. So, next one is frequency times class mark. So, pagta-times natin yung 2 and 72.5. So, para mas mabilis, type natin yung equals and then select natin yung 2 times 72.5 equals 145. 3 times 66.5 equals 199.5. 7 times 60.5, 403. And then 8 times 54.5, 436. 9 times 48.5, 436.5. 9 times 42.5, 2 times 36.5. So, ayan yung ating frequency times class mark. So, the total natin siya. So, the summation of frequency times class mark is equal to 2,096. So, ayan yung ating sum. So, kaya natin tinotal yung fx para makuha natin yung mean. So, to get the mean, we have mean is equals to the summation of fx over n. So, yung ating summation of fx is 2,096 over 40. So, i-divide lang natin tong dalawa. And we have the mean of 52.4. So, dito naman, ang gagawin natin is i-minus natin yung class mark sa mean. And then, yung sagot nila is isa-squared natin. So, 72.5 minus 52.4. So, ganyan yung gagawin natin. And then, isa-squared natin siya. So, 20.1 squared is equals to 404.01. So, ganun din dito sa mga sunod. 66.5 minus 52.4 equals 14.1 and then squared equals 198.81. So, ulitin lang ulit natin. 60.5 minus 52.4 squared equals 65 minus 61, 54.5 minus 52.4 squared equals 4.41. 48.5 minus 52.4 and then squared 15.21. 42.5 minus 52.4 and then squared we have 98.01. 36.5 minus 52.4 equals 252.81. Next naman is ito times natin yung sinolve natin na x minus x bar sa frequency. So, unang column is 2 times 404.01 equals 2 times 404.01. We have 808.02. And then, ganyan lang. Tuloy-tuloy lang natin siyang i-times. So, 7 times 65.61. 8 times 4.41. 9 times 15.21. 9 times 98.01. 2 times 252.81. So, ayan. So, ito-total natin to. The summation of f times x minus x bar squared. Ayan. Total natin to lahat. So, we have 3423.6. So, ayan yung ating sum. After natin ma-solve lahat to, pwede na tayong mag-compute for the variance. So, the variance is s squared equals the summation of f times x minus mean squared 2 divided by n minus 1. So, meron na tayo nung total, nung summation ng f times x minus mean squared. So, lagay natin siya. We have 3423.6 divided by 40 minus 1. So, s squared equals 3423.6 over 39. So, i-divide natin yung 3423.6 divided by 39. S squared equals 87.78. So, ayan yung ating variance. Dahil nakuha na natin yung variance, pwede na natin kunin yung standard deviation. So, yung standard deviation is yung square root lang ng ating variance. So, the square root of 87.78, we have 9.37. So, ayan yung standard deviation natin. And that's all po.
So hi guys, I'm Evan C. and I'll be doing the manual computation of the ungroup data of the measures of variability. So tutorial on how to perform manual computation of measures of variability for ungroup data. Here are a step-by-step explanation for each measure of variability, with detailed reasoning and instructions to ensure I can explain it as a tutorial. So, as we can see in the image, the range, the range is the simplest measures of variability representing the difference between the highest and lowest values in a dataset. So step 1, identify the highest and the lowest values. Look at your data and determine the largest number, which is the highest score, and the smallest number, which is the lowest score. For example, the higher score equals to 75 and the lowest score equals to 38. Then step 2, subtract the minimum value from the maximum value. This gives the range of data showing how spread out the values are. So our formula will be the range equals highest score then minus the lowest score. For example, range equals 75 minus 38 then equals to 37. Explanation: the range tells us the simplest measure of how much the data varies, but it only uses 2 points in the dataset. Let's move on to variance. Variance measures the average square deviation from the mean. It's a key step in understanding the spread of the data. Steps: find the mean, add up all the values in the dataset, and divide by the total numbers of values n. As you can see in the example, sum of scores equals 2,102, then n equals 40. So as you can see, there is our formula shown below. Step 2, calculate the deviation. Subtract the mean from each data point. These values can be positive or negative, depending on whether the score is above or below the mean. Example for a few data points. For our mean one, as you can see in the image, and then for our mean two, you can see there. So our step 3, square each deviation. This ensure all deviations are positive and emphasizes larger deviations more. For like our example, as you can see there. So we move to our step 4, sum all the square deviation. Add up all the square deviations to get the total square deviation. So our example show in there. So you guys will know what to do and how it will become after doing it. Divide by n, our step 5 for population variance. This gives the average square deviation, which is the variance. So there is our formula, guys. The variance. Then our example. So it's shown there. And we got our variance, which is 81.25. Explanation. Variance tell us how far data points spread out from the mean on average, wherein the deviation removes negatives and weights larger deviations more heavily. So let's move on to standard deviation. The standard deviation is the square root of the variance. It measures the typical amount by which data points deviate from the mean. So our step 1, start with the variance. Use the variance value you just calculated. So as you can see, there is our example. Then let's move on to step 2. Take the square root of the variance. This brings the unit of measurement back to the original scale of the data. So for our formula, as you can see, and then our example. So my explanation, standard deviation is more initiative than variance because it's in the same units as the original data, making it easier to interpret. So let's go to mean absolute deviation or MED. Mean absolute deviation measures the average of the absolute deviations from the mean. It's less sensitive to extreme values than variance. So our step one, find the mean. Use the same mean calculated earlier, which is the 52.55. Then step two, compute the absolute deviations. Subtract the mean from each point and take the absolute value to avoid negatives. For example, for a few data points, as you can see, the mean 1 and the mean 2, the images shown below. So 3, sum the absolute deviation. Add up all the absolute deviations together, for example. So there we got the 303.10 divided by n. This gives the mean absolute deviation. So as you can see, that's our formula, guys. So let's go to the example. In there, we get the 7.58. So my explanation again, that mean absolute deviation provides a simple average of deviations and is easier to calculate than variance while still showing data spread. So lastly, interquartile range or IQR. Interquartile range measures the range of the middle 50% of the data, making it resistant to extreme values. Steps. Step 1, sort the data in ascending order. Arrange all values from smallest to largest, like it's the lowest scores to highest scores, guys. Then, 2, divide the data into halves. Lower half, the data below the median, then upper half, the data above the median. Then, step 3, find the first quartile, Q1. This is the median of the lower half. Example, Q1 equals 45.0. Then, step 4, find the third quartile, which is Q3. This is the median of the upper half. Example, Q3 equals 59.5. Then last 5, subtract Q1 from Q3. So, our formula, interquartile range equals Q3 to minus 2 Q1. Then example, IQR equals 59.5 minus 45.0. Then that's our interquartile range, 14.25. The explanation that the IQR is useful for identifying the spread of the central portion of the data, ignoring outliers. So, manual computation of measures of variability for ungrouped data is important because it deepens understanding of the data spread and provides insight into the underlying distribution. By manually calculating measures like range, variance, and standard deviation, mean absolute deviation, and the quartile range, one develops a stronger grasp of how each data point contributes to overall variability. It also promotes familiarity with the formulas and helps identify potential errors or anomalies in the data. In addition, manual calculations promote critical thinking as you can visualize how changing individual values affects the variability measures. Furthermore, this process reinforces the importance of central tendency measures, which is mean median mode, as part of the broader statistical analysis. While software tools can automate the process, performing these computations manually ensures a more thorough understanding and strengthens analytical skills, especially in a situation where tools are unavailable or impractical. It also builds a foundation for handling more complex data analysis tasks in the future. That's all, guys. Thank you.
Hi everyone, I am Jasmine Costales and I'll teach you how to calculate the measures of variability using Excel for both group and ungrouped data. First, we'll work with ungrouped data. For this, we'll use a dataset of 40 exam scores from students in a psychological statistics course. To find the range, which is the difference between the maximum and minimum values, find the minimum first by typing equals mean, highlight the data range, and then press enter. For the maximum, type equals max, highlight the data, press enter. For the range, subtract the subtract the minimum value from the maximum value to get the range. So equals max minus the minimum and then press enter. Now to calculate the variance, type equals var, here the sample, and then highlight the data, press enter. For the sample standard deviation, type this, highlight the data, and then press enter. This gives you the sample standard deviation. Now, now for the interquartile range, the interquartile range is the difference between the third and first quartiles. Here's how to calculate it. For the first quartile, type equal quartile, this, select the data set, add comma, and choose this, type 1. Close the bracket and press enter. For the quartile number 3, repeat the same process but replace 1 with 3. So equal quartile, highlight the data set, add comma, and then press 3. To compute the interquartile range, type equal, click on the third quartile, then subtract the first quartile value, and then press enter. And that's how you compute the range, variance, standard deviation and interquartile range for ungrouped data using Excel.
Hi everyone, I'm Melissa Castabel Badajos, one of the member of Group 3, and I am the editor of this group. Thank you for watching our video.